So very good morning to all of you present here. We're going to start the webinar in another 2 minutes, waiting for a few more people to join in. You guys will be note that today we have a very distinguished speaker with us who's going to be taking this webinar. And that speaker is Dr. Sonia O'Brien. She hails from Australia. She has a background in veterinary embryology. She did a thesis on ovine nuclear transfer back in Italy, and then she did a PhD in equine assisted reproduction from Colorado. And since then, she's been working with Cook. She has been working in different setups right from Amsterdam, and now she's actually in Melbourne. And she's now part of Cook's global clinical specialist consultants team for Australia, New Zealand, as well as Southeast Asia. And we're looking forward to her to speak on humidity and osmolality, influence of variables on the rate of osmolality rise in a dry incubator setting. And this is a difficult topic, and it's a very important topic as far as embryology is concerned. So if you have any questions, please do put it in the chat box, and Sonia and I would be here to answer those queries for you. If you are having any problems with the audio or the video, now is the time to actually check your internet connections, and I think we're going to start in another minute or so. So if you can give me a thumbs up if you can hear the audio. Sonia, you can also speak.
Okay, great.
Just to check the audio.
Great, thank you, Keshav, for the kind introduction. And can we see a thumbs up from anyone who can hear us? Fabulous.
We've also put in some poll questions for all of you. So before the webinar begins, you can actually go ahead to the polls column and answer those 3 questions. That will help Sonia a lot, and she can take that discussion forward from there. So if you notice, there are 4 columns here: the chat bar, the question bar, and the poll bar. Just go to the poll section and answer those questions for us, please. Okay, I think the audio is clear, Sonia. We can begin the webinar.
Okay, fabulous. Thank you so much, Keshav, and I'm really pleased today to be able to present on humidity and osmolality, and more specifically, looking at the influence of different variables on the rate of osmolality rise in a dry incubator. These were experiments that were done by Steve Mullen, who is from Cook Medical, and he's a senior scientist in the US with Cook and a team leader in cell culture and media development. And obviously, as a disclosure statement, I have to say that both myself and Steve are employed with Cook Medical. So let's have a look at the at how to define the problem. First of all, the reason why we started looking into this is because uninterrupted culture of human embryos from fertilization to blastocyst stage has become quite common. And I don't see anyone who's answered the polls, but I am sure that many of you are doing uninterrupted culture from fertilization.
If I can interrupt you here, I don't know why you're not getting it, but 57% of the attendees say that they do uninterrupted culture.
Yes.
67% use dry incubators, and 90% of them feel that equilibrating oil makes a difference.
Fabulous. Thank you so much, Keshav. So, as I said, and I was sure about that most of you are doing uninterrupted culture. Quite often, culture is done in microdrops, 20 to 50 microliters of medium under oil, which possibly has been equilibrated. So 90% of you do pre-equilibrate the oil in a humid environment. Culture in a non-humid incubator, so a dry incubator, is common. About 67% of you are culturing in a dry incubator. And although oil reduces evaporation substantially, it does not prevent it. So what we wanted to do is look at how much evaporation occurs. Is it actually enough to be a problem impacting human embryo development and quality of embryos in vitro? What variables affect the rate? How does the media chemistry change? And are we and how can we maintain safe culture conditions? So the research was done to try and identify an answer to all of these questions. So first of all, is it actually a problem to culture in dry environment? There are results from a small number of published studies that have been reported. So from there, we saw that there is actually enough data to think about osmolality in culture. All suggest that embryo quality and pregnancy rates, when these are reported, are better when embryos are cultured in a humid environment. So I'll quickly go through 3 papers that we looked at. The first one is by Rebecca Holmes, and she presented this abstract at ASRM last year. And she compared humidified versus non-humidified incubation with sequential culture media in a time-lapse incubator using sibling oocyte splits. And what she noticed, looking at the blastocyst development under humidified or non-humidified conditions, is that the humidified chamber in the green bar here yields significantly more good quality, so greater than grade 3 BB on the Gardner scale. So good quality blastocyst with about 24% day 5 blastocysts, about 49.5 day 6 blastocysts, and about 51% day 7 blastocysts. So already in her case, even though the numbers are small, she identified that she has better quality blastocysts in a higher number. The second abstract was from 2018, again presented at ASRM by Raquel del Gallego. And she also looked at humid versus dry embryo culture conditions on the embryo development in a continuous embryo monitoring assessment, so in time-lapse. And again, what she noticed, looking at the embryology and the pregnancy outcomes under humidified or non-humidified conditions, was a clear improvement on the embryo development and the subsequent IVF outcome, so pregnancy rate, when the embryos were cultured in humidified atmosphere. So again, the green bar is humidified conditions, and there's about 70.5% of blastocyst development, total blastocyst development. Pregnancy rate, she had 83% pregnancy rate in the humidified conditions, and she had a higher miscarriage rate in the purple bar with about 26.5%. Another thing that she noticed is that under the humid conditions, the embryos reached the 5-cell stage earlier than in dry conditions. So she was thinking, because they also did a measurement on the culture media, on the spent culture media, that there might be a trend in increase of oxidative stress levels in the media that was analyzed in dry conditions. So she raised the question, does humidity improve culture stability? And the last paper we looked at is a paper from 2017 by Mohamed Fawzi, and he looked at humid versus dry incubator. And this is a paper looking at prospective randomized controlled trials. And he was culturing up to day 5, day 6 And again, looking at the embryology and pregnancy outcomes under humidified or non-humidified conditions, we saw that for day 3, there was a high quality embryo rate, which was significantly lower in dry culture than in humid culture. So we have 83% top quality day 3 embryos. Looking at the blastocysts, the high quality blastocyst rate was significantly lower in dry culture compared to humid at 61%. And also, if you look at other characteristics, they saw that the embryo quality at compaction was lower in a dry environment, and there was a lower rate of blastocyst formation. The quality was lower as well, but also the cryopreservation rate was lower. And of course, you can see that there was a significantly lower rate of clinical and ongoing pregnancy rates with decreased implantation. So because of these papers, we looked at the fact that all of these suggest that there is a definite trend for embryo quality and pregnancy rates when reported, and that it is better when embryos are cultured in a humid environment. So this is something we wanted to look at more closely. The problem is that all of these papers will use different ways of studying. So we actually tried to make it more of a stable environment. So a number of factors have been suggested to be related to the evaporative loss phenomenon. Of course, there's the humidity levels. In a dry environment, often it's less than 10% relative humidity. So it is a very desiccating environment that we're culturing in. Then, of course, there's the oil type, the viscosity, the density. Does it have an effect? There's also the initial oil humidity. And there are many conflicting reports in literature if equilibration actually does help or not. Then there's a volume of the drops and or surface area of the drops exposed to oil. Obviously, the higher the surface area to volume ratio, one would expect the higher rate of evaporation. And that is all related to geometry of the media in the dish. Then you have the oil depth or volume above the drops. So this also depends on how much volume you're putting, volume of oil you're putting in the dish to the size of the drops. And finally, you have to consider the incubator type and manufacturer. This may also have an effect. For instance, it could depend if you have a continuous or a non-continuous gas flow. So we're going to try and have a look at all those factors. So the first experiment, here we have results measuring the rate of the osmolality change in humid versus dry conditions with 3 different oils from different manufacturers. So the general conditions were 30 microliter medium drops with an overlay of 3 ml of oil in a 35 millimeter dish, and time 0 equals the time the dishes were placed into the incubator. The solid lines represent a humidified incubator, so at about 75 to 80% relative humidity, and the dotted lines represent a dry incubator, so at about 10% relative humidity. And of course, the same color line represents the same oil, but in a different environment. So the first thing we can notice that there's a significantly greater slope or rate of osmolarity change in the dry conditions over time, if you compare that to humid conditions. And even with the best oil, so if we're looking, for instance, at the green dotted line will go over 300 milliosmol at 3 days. So in the humid environment, when you look at these solid lines, there is, of course, an increase in osmolality. But what's interesting is that with the humid environment, the type of oil doesn't have a very strong effect on this phenomenon. In fact, there's no statistical difference between those slopes. But when you go to the dry environment, depending on the type of oil, there is a statistical difference. And on the other hand, if you do sequential, so if you change at day 3, you might actually not see enough of a osmolality increase in the dry condition. Perhaps it's not even enough to notice any difference. But you can see here that if you look at these results, there is definitely a greater rate of change in dry conditions. And also the type of oil affected the rate of change. Another way of looking at it is in this table. If you look at just the osmolality change, in a dry environment, you will have anywhere between 4.5 to 7 milliosmols change within 24 hours. I see Keshav, yes, actually, because I've got another graph afterwards where we have combined mineral oil. There's different types of oil, mineral oil and paraffin oil. So if you look at the osmolality change in a humid environment, either way, if you have the paraffin oil or if you have mineral oil, you have a change that is only of just under 2 milliosmol per day. So in conclusion, in this specific case, if you are in dry conditions, you will see a change of osmolarity even with the best oil. I'm quickly going to have a look at the questions. Are the faster cleaving embryos good for transfer? That's probably something we need to check with the author on what results.
No, so you mentioned here that when you have different conditions in the incubator, some of the embryos would cleave faster in a scenario, probably in a dry incubator as compared to a humidified incubator. So just
yes.
taking that point into consideration, do you think such embryos are like good for transfer? Or
well,
because we've seen in our laboratory as well, like there are times where you would get a good blastocyst on the end of day 4, like a fully expanded blastocyst on the end of day 4. And then we are worried whether it's cleaving faster than normal, is it genetically normal or not? There are lots of questions which happen there.
I do think that the type of culture media has a high influence on the speed of cleavage. Some embryos from some patients seem to cleave quicker than others. That's another thing that I've noticed across labs. So you can't really do a generalization. I think you need to see in your system how quickly the embryos cleave, but you also have to look at the embryos of that patient because she might have embryos that cleave quicker generally. So I don't know if you really can do a generalization. And there was another question about changing media at day 3, even if we're using one step. It seems like, yes, because of the fact that whatever amount of oil you're going to put, and even if it's a better oil or good quality oil, it seems like it still influences the osmolality of the media. And I've got one of the graphs that actually shows that as well.
Perfect.
Can everyone see the slides?
Yes.
Yep. How much time should we pre-equilibrate? Okay, so I've got my next slide that looks at that. So we actually did an experiment examining the effect of pre-humidification of oil before its use on the rate of osmolality change. Now, what we were doing is look at this specifically because there were conflicting results in literature. So what Steve did is that he put oil in a humid incubator prior to the start of the experiment. So 0 time, so he just used it as is without humidifying the oil. He put it for 1 day to equilibrate or for 5 days to equilibrate prior to use. And then he used the oil just as you usually would to overlay 30 microliter medium drops in a 35 millimeter dish. And all of this is done in a dry incubator this time. So what we identified is if you use pre-humidified oil in a dry culture environment, is this actually going to slow down the change of rate in osmolality? If you look at the graph, so black line is no humidification, green line is 1 day, and red line is 5 days. Unfortunately, the 3 lines actually show a very similar, practically parallel slope. And that would actually suggest that there is no benefit to pre-humidifying the oil. So in a dry environment, so I'm talking about dry environment. In a dry environment, it doesn't seem to make any kind of difference if you pre-humidify the oil or not when you're culturing. And that can also be seen here where he did a calculation of the confidence intervals with the 3 slopes. So does oil storage and transport temperature also affect the quality of the oil? It does, but it does not. So it's not going to make a difference in this case with the humidification, but it does definitely affect other factors of the oil. So we all know that some oils sometimes are toxic compared to others. When the manufacturer does its testing on the oil, when it goes out of the factory, it seems it's all good. But the moment that you put it in bad storage conditions, so in light, or if you heat it, obviously it can become toxic to the embryos. But it doesn't affect this specific condition of the oil. So if you're working with dry conditions, the equilibration of the oil actually does not make any difference, as you can see here. So now we looked at examining the effect of oils from different manufacturers, and more specifically 9 different oils from 5 different manufacturers on the rate of osmolality change in dry conditions. And it's still the same 30 microliter drops under 3 ml of oil. So we looked at the osmolality rise with different oils. Now I'm still going to take 3 days, but after 3 days or after 5 days, what you can notice in dry conditions is that you still have a rise. So at 5 days, here we have 312 milliosmol up to nearly 355 milliosmol, depending on the quality, or not the quality, sorry, the type of the oil. So there is quite a big span if you look at the different oils. So we saw that there is actually quite a big change in the rate of osmolality change per oil type. And we also looked at the confidence intervals, but these do overlap somewhat. But what's interesting is that this is all in dry conditions between the different brand of oils, the 24-hour rise in osmolality. So it goes from about 3.8 to about 8 milliosmol per day under dry conditions. And then if you look at the expected value under humid conditions, it's still much lower, on 1.56 milliosmol than in all the other groups. Even again, with your best oil, you will get a difference of 3.8 milliosmol per day in a dry incubator. So you definitely have more of a change in osmolarity in a dry environment compared to what you would have in a humid environment. So we can see that with whatever oil you are using, there is still using a humid environment is best.
Okay, there are some questions here. First of all, I think people are asking, can we reuse equilibrated oil multiple times? And so if you've equilibrated oil, and can that go back into the refrigerator and then can you use it again?
It's usually not advised.
It's not the best practice, right?
No, it's not.
Yeah. And any best practice ways of equilibrating oil, from what I've tried to understand here, that maybe pre-equilibrating doesn't really make that much of a difference.
If you're using it in a dry environment, and definitely not mixing media with it, because we've seen that that's when the oil becomes toxic really easily. So I know that in the past, because I've done it myself, we used to wash oil with media. But we've actually seen that it can make the oil more toxic if that oil is one that has issues.
Okay.
And the best way to equilibrate oil would be the same than the way that you would be equilibrating your media, so overnight. But in a dry environment, all of that water, because oil still absorbs a little bit of water, but all of the water that will have been absorbed by the oil will evaporate in the dry environment. And remember also that even through dishes, there's actually an evaporation as well.
Perfect. Thank you.
So then we were trying to examine the effect of oil from different manufacturers on the rate of osmolality change, but based on these oils' different kinematic viscosity and density. So viscosity being the thickness, the resistance to flow, and density being how tightly packed the molecules are in a solution. If you look at the graph on the left, which is the one with the viscosity, you can see that the slope coefficient shows a trend towards higher rates of rise in osmolality as the viscosity gets lower. So obviously the viscosity does have an effect on osmolarity rise. If you look at the graph on the right, which looks at the density, we can see that the effect is actually pretty strong with a linear correlation in this case. And as the oil density gets higher, the loss in water gets lower. So another way of looking at it is as the density gets lower, the osmolality changes and gets higher. And this is a pretty tightly correlated relationship. So one of the reasons for doing the regression analysis was that we were trying to develop a mathematical relationship between all of these different factors. So there may be some equation that we can develop in the future that can be used to predict this phenomenon of osmolality rise based on different factors, such as density, viscosity, volume of oil, and the volume and the height of oil, because all of these may contribute independently to some degrees to the change of osmolality. So what we were trying to do is develop this predictive model. But what we could notice here is that oil properties do affect osmolality change, and no oil can compensate fully for dry conditions. While media preparation oil exposing long time in room temperature, does it affect embryo formation? Okay, so if you do take too long to prepare your dishes at room temperature, it does actually have an effect, but it does depend also on the surface area, which is also what we looked at. So that's where this experiment came into place. So we tried to examine the culture media volume, surface area, and oil layer height. So we examined media volume, 40 to 1,060 microliter, and oil thickness, 1 to 5 milliliter on osmolality rise. We had to use these 96 well and a 5 well plate, and we didn't do drops. Now, the reason why we didn't use drop forms is because everyone does drops in a different way. So the volume and the surface area are tightly correlated, and you can't separate the two effects. So one person might do a drop that is slightly different to the other, although both are the same volume, the surface area is different. So to have a fixed geometry, we actually used these plates because we could have an independent variation of surface area and volume. So we could alter the volume of the media, as you can see here, but keep the surface area fixed. So you could independently vary these two factors. And the drop volume, if you see here, between 20, 30, 40, 50 microliter, we considered that in the 96 microliter well dish, it was the best option. And then we used a 5 well dish because that is quite commonly used. But one of the things is that if you know the geometry of the system, you can calculate the height of the oil based on the volume of oil you're overlaying. So we knew that 1 ml of oil in a 35 millimeter dish is approximately 1.1 millimeter thick, for instance. So all of the next experiments that I'm talking about, we are not having drops. We're using these two 96 well and 5 well dishes. While media preparation, oil exposing long time, yes, and does exposing, oh, definitely. If you use 37 degree centigrade, you have to consider that there's going to be more evaporation from that oil. It's not going to be toxic per se, but it is the fact that you're going to use a dry environment that's going to cause an issue. But using it at 37 degrees, if you're in a humid environment, all of the media, all of the manufacturers have actually checked how long the oil can be in an incubator. The difference is if they have looked if it's in a dry or a humid incubator, it depends on the company. Because as I was saying at the start, every company has got their own incubator. Normally, it shouldn't, we all have done our experiments up to day 6, even day 7. or longer. Day 7 is, from what I know, most of the companies have done their tests until day 7. So keeping in mind what I was saying earlier, that we use 2 different types of dishes, we started looking at the combined results on the effects of medium volume, medium surface area, and surface area to volume. So if we look at this first graph on the left, the top one, which is medium volume and osmolality rise, we notice that with a fixed surface area, the biggest effect is when the medium volume is lowest. So the same amount of water evaporating, but with a smaller volume, you have an osmolality rise that is faster. So if you look at bigger volumes of media, obviously you have a lower osmolality rise. So this is why medium volume actually has a big effect. The smaller the volume, the faster the rate of osmolality rise. And this does make sense. Here we have the medium surface area and the osmolality rise, and we have only 2 different surface areas because we use the 96 well plate and the 5 well plate. So we only had 2 geometries. The smaller the surface area seems to have a higher effect, but that's because the surface area goes up with the rise in osmolality going down. And that's because if with a bigger volume, you have is associated with the surface area. But if we combine those 2, so if you look at the medium surface area volume and osmolality rise, we have actually a surface as the surface area to volume increases, we see an increase in the rate of osmolality change. Now here we had the 96 well plate in the middle and the 5 well plates that kind of were going on both sides. Because everything kind of fell in line, we actually combined all of that data. So we considered that it was experimentally acceptable to just combine the results between 96 well plate and 5 well plate. And it kind of makes sense that the surface area to volume has an effect on the osmolality change, because if you have the same volume and you spread out that drop, then you're going to have more evaporation. But an easier way to look at it is actually on this graph where we combined all of the data together. So we combined having the interaction of the oil height and the surface area. Now, if you look up here at the front, you can see that whatever oil height we're using, so from minimal oil height to 6 millimeters of oil height, there's actually not a big difference. Whereas that effect becomes much stronger if you increase your surface area to volume. You can see that there's a rapid increase in the change of osmolarity, even if you put quite a lot of oil on top. You're still going to have a more rapid osmolarity change, even though you've got quite a lot of oil. And we're talking here about 6 millimeters of oil. That's actually quite a lot. It's obviously less dramatic than if you don't have any oil on it, but you will still see a change. So the surface area to volume ratio effect is quite strong, but it is depending on the oil height. So interestingly enough, there is a formula that Steve was trying to identify, and this is what he's working on at the moment. He's actually doing quite a few experiments to even make this formula more sophisticated, because we could consider that if we have the physics worked out, then you could actually predict under your scenario in your lab if it does make a difference. So this is actually making it even easier to look at. So it's the same graph than before, but this time we're looking at this black surface representing the expected value in humid conditions. So anything that's above this black surface means that it is actually a more rapid change in osmolality. Now, we're looking at this with 30 microliter drops of medium and 3 millimeter of overlay of oil. So it's important because this intersection of these two planes would be the conditions with which you would expect to see similar rise in osmolality over time. So if you look at this intersection of the black and red plot, it gives you an indication of under what conditions you would see the similar rates of osmolality rise. And in dry compared to a humid environment, you would expect to see that sometime around when you have a surface area to volume ratio of anywhere between 0.4 and 0.5, you see a change. So in culture condition, this is where you would see some kind of a change in your geometry. So under microdrop condition, if you look at this graph, the condition, the surface area to volume is way past 1. So under microdrop conditions, you need a really high level of oil to avoid having an osmolality change. Now, again, I'm talking about dry incubator, not humid incubator. So you can see that the surface area to volume and the oil height does affect the osmolality change. And another way of looking at it is because Steve had done results with his microdrops, he actually had looked at the drop volume and its effect on the osmolality. So if you look at this, increasing the drop volume is obviously beneficial in a dry environment, but it's still not good enough to get you the same than what you would obtain in a humid environment. So every day that you culture in dry conditions, you expect the osmolality to rise. For 30 microliter, you're going to have a raise of about 0.2. For 40 microliter drops of about 0.22, and for 50 microliter drops again for about 0.22. But if you look at it with 25 microliter in a dry environment, you have a raise of milliosmolality per hour, of about 0.29, which again, all of these are way higher than if you culture in a humid environment, where you only expect about 0.07 milliosmol change. So if you remember in a 35 millimeter dish that about 1 ml from bottom to top of the dish is about 1 millimeter height. So even at 5 ml, you would have about 5 millimeters of oil, which is a huge amount of oil. So microdrop culture in dry condition is never as good as the humid condition. So do you think we need real-time monitoring for osmolality changes in the future? Well, I think it's actually hard to do real-time monitoring because, for instance, the osmometer that we were using is a vapor pressure osmometer, and it is extremely hard. It is a very accurate way of monitoring, but it is actually really hard because you need to make sure that it's always measuring correctly. So I think that's where the problem is, that yes, ideally it would be great, but it is a hard measurement to measure.
Can I just interrupt you here?
Yes, of course.
When the osmolality changes, so this is for the audience here, are there any changes in the embryos that an embryologist can see and then change the media at an appropriate time before it's too late? Or so how would the embryo behave in such a scenario? Would it just die, or there are subtle changes that can be noticed early on? Can you hear me?
Everyone's gone quiet.
No, Sonia, can you hear me?
Yes, I can.
Okay, so
I thought you said for the audience. Oh, okay.
Okay, so that was for you.
So when you look at the different papers, what I have seen is that, for instance, in this paper by Rebecca, it's not in this graph, but the number of total blastocysts obtained was similar in humid and dry, but the number of good quality blastocysts was significantly different. So in her case, that's what she was looking at. So possibly this is one of the variables that would be different, that in the total quality in her case was similar. The total number was similar, but the quality was different.
And is this the same for like sequential media and single step media? Because like we know that we're changing the media on day 3 for a sequential media. So that would be really changing the osmolality as far as the single step is concerned. Because in single step, what usually happens in India is that you keep the dish for 5 to 6 days without doing any kind of changes. But for sequential, obviously, when you change the media, you're obviously improving the quality of the osmolality, or the second media would not have those osmolar changes. So your views on that?
So again, in her case, she was refreshing the media at 24, 72, and 120 hours. And they were looking at the embryos. So in her case, it probably wasn't linked with evaporation. But in the case of especially, let me see, I think it was Mohammed. In his case, he literally left the embryos from day 0 to day 5 to day 6 of culture. So I know that we are saying that, of course, uninterrupted culture has got the advantage that you are not taking out the embryos from the incubator. But I think a lot of us as companies are looking at, even if you're using uninterrupted culture, it is working better from what we can see for the embryos if you're using it under dry environment. If you use it under humidified environment than under a dry environment.
Perfect. And so when we compare a box incubator with a benchtop humidified incubator, are there any differences between the two as far as the humidity is concerned?
With the humidity, it depends in the box incubator. Obviously, I'm not going to talk about the fact that it loses temperature much quicker and your pH has a lot of problems coming back to pH because of the loss of gas. But with the humidification, it really depends on the amount of humidified air that it is pumped back in the incubator. Also, the reason why we moved to benchtop was to avoid having all of those water pans that were getting contaminated, obviously, at the bottom of the incubator. So, suggestion is if you talk only about humidity, it sounds better because it's really humidified. But if you look at a benchtop incubator, if you have continuous humidified gas going through, then that is actually better because you have a smaller environment to humidify. So you know that that small space is completely humidified.
Okay.
How were they cultured, droplet or large volume? So if you look at the, I can actually tell you that. The first paper, they were done in the Jerry. So that is 80 microliter, I believe. The Jerry uses 80 microliter. From memory, I think you can put in up to 4 ml of oil in the Jerry. So that was actually quite a high volume of oil that you can use in the Jerry incubator.
Yeah.
The second abstract was also done in the Jerry, so same amounts. And the third one, they were 15 microliter droplets under 5 ml of oil. To answer those. Oh, another thing we looked at is, does the number of droplets make a difference? So we were thinking, okay, so with the oil, does it make a difference if we have more droplets under the same amount of oil? It actually doesn't. So that's another item that we looked at. In a dry environment, you still have the same rate of evaporation. And thanks, Kashish, for confirming the 80 microliter and 4 ml of oil. So, I mean, this is work in progress from Cook Medical. That we are still, Steve is still doing more experiments to try and identify. I'll answer your question in a minute, Shanti. So we still think that dry incubation conditions result in osmolality change over time. That because also published reports indicate that culture in a humidified environment provides superior results, and that the rate of osmolality change is affected by the oil properties. So one of the things we are looking into doing is actually look at not only the density and the viscosity, but also the chemical composition of the oil, and seeing if that makes how much of a difference that also makes. Viscosity is not as significant as density. If you remember, there was a linear regression with density. Oil properties have a much smaller effect on the rate of osmolality change under humid conditions, as we saw that even the better oil under dry conditions causes a change in osmolality. In our hands, the pre-humidification of the oil did not reduce the rate of osmolality change, and that's because in dry conditions, less than 10% of humidity, relative humidity, evaporates very quickly. Rate of osmolality change is affected by oil height and medium surface area to volume ratio. And at the end of the day, we belief from the experiments done until now by our engineer is that microdrop culture in dry environment is unfavorable compared to humid conditions. So really, what we're trying to do here is get a formula. So hopefully in the future, Cook will be able to give you a formula where you can just put in volume of drops, volume of oil, size of your drops, and from there be able to identify what the daily osmolality change is in a humid and or a dry environment, rather than having to measure it on a daily basis, as you were saying, Keshav, because that's really complicated.
Yeah.
Okay, so EmbryoScope is a dry incubator. Well, they're coming out with the humidified EmbryoScope. So yes, I do agree that they say that it produces better embryos, but even they are now moving to a humidified EmbryoScope. So there must be a reason for that they moved to the humidified version, which is, if anyone knows the name, obviously I don't work with Vitrolife, but I think it's EmbryoScope Plus or something along those lines, is a humidified incubator. And again, I do also believe that not moving the embryos, leaving them in place has got an advantage.
Yeah.
So probably that's my best answer to that question. Does that mean large volume of media to be used for dry incubator? Yes, you need to have a close look at the volume to surface area of the media that you are using. The smaller the, if you look back at, if you look back at this graph, the surface area volume is really important to the amount of oil height, being oil height at 6 here at the back. But the problem is, as we were saying, microdrop culture, you're up here, which causes a high change. However, now with the change of incubators, you find that a lot of the incubators, and I'm thinking more of the time-lapse incubators, they've got fixed volume of media to oil.
Yeah.
If you use a dry incubator, you are always going to see a quicker change in osmolarity change. So perhaps even changing the media at day 3 in a dry incubator is probably your best answer to this question, Shilly. Another thing I just wanted to say is that this presentation has been done already at the Southwest Embryology Society in the US in January, but it will also be presented at Alpha in April. So if you're lucky enough to go to Alpha this April, and if you want to talk to the man who actually has done all of these research, and also he will have more information by April. That's what he has promised us. And we will also be coming out with a white paper based on all of this data, if anyone is interested. Does anyone have more questions, or do you have questions, Keshav?
So thank you, Sonia, for that wonderful presentation. We have about another 15 minutes where we can take questions. There are 2 questions in the question bar. I'm just going to ask them for you. So the first one says, for K system, what will be the ideal droplet size for culture?
Ooh.
From what I know, K systems is also a dry incubator. So again, maybe having a larger surface area covered by oil should be the way to go, or your views on it?
So does K systems have a specific dish that you use in them, or can you use different type dishes?
I think we can use different dishes.
different dishes.
Yeah.
So again, you just need to, if you're intending to use a dry system, and if you're intending to use uninterrupted culture, it's not ideal, obviously, but again, the bigger the volume of media you will have, the less the evaporation. However, if you believe that, because again, a lot of papers are saying that smaller micro drops, if you put 3 embryos in them, the better embryo gives, permits the other 2 embryos to grow better. You have to work with what's best in your lab. I would advise a change of medium at day 3, but that also depends on how you work in your lab. You can even do your own evaluation by looking, if you change at day 3, if you actually see a change in the good quality embryos, for instance, or set yourself a result that you want to achieve or improve, a KPI you would like to improve in your lab, and you could notice that it gets improved. In our hands, we've noticed that with a dry incubator, there's always a change in the osmolarity from day 3.
So I really like that strategy that you've just mentioned, where anyone now who's interested in these osmolality changes can actually look at their good quality blastocysts on day 5 and day 6 as a KPI and see whether that improves when they change the media on day 3. So if that works for you guys, do put in an email to me and Sonia that you tried this out and it worked for you, and we'll be very happy if you can share your outcomes with us. The next question is that, okay, so if you're working in a closed chamber, is that better as far as osmolarity changes are concerned or not?
Closed chamber, so a benchtop incubator style, smaller.
No, so closed chamber is the laminar airflow, which is like closed. So it's a closed workstation.
Yes. So when you're making your dishes?
Yeah. And even working during OPU or changing the dishes or whatever.
Yes. So when you make the dishes, obviously we all know that there's 2 trends. I know that I think Jason Swain was talking about the fact that if you use a laminar flow, and for instance, Jim Cat also mentions that if you use a laminar flow when you're making your dishes, you might have a more rapid evaporation. Yeah. On the other hand, and I cannot remember who was talking about that, you might have, sorry, I'll just check that because I actually do know where that paper is from. When you do that, you might have more contamination if you don't use the laminar flow. And I think that's possibly from Brinster. So I would say the best way of doing it, if you use or not the laminar flow, is to actually, even if you've got a lot of dishes to make, unfortunately, is to make a smaller number of dishes at a time. So using the laminar flow or not is very dependent on how your lab manager or the scientific director prefers. I mean, all of us have got a protocol to follow, obviously, from the lab. If you don't use the laminar flow, as long as you do it at room temperature, definitely do not do it at 37 degrees because that has a high influence. So don't do it on a heated surface area. But if you use room temperature, cold, medium, and you make your dishes fairly quickly, and don't try and do too many dishes at the same time, the use or not of the laminar flow doesn't seem to influence too much. But a lot of the people that I know always say not to use the laminar flow. But on the other hand, you could get contamination if you don't. So
that's what I've also heard in the same scenario, and we do it in our labs as well, where we would switch on the laminar flow before making the dishes. But as soon as we get the dishes out, the laminar flow is
Yes,
shut
goes
down so as
off.
to avoid evaporation.
Exactly. And I think that's a good intermediate way of doing it.
Yeah, I don't know.
To avoid. Well, it's a good. That's a good way of doing it in the middle. That
Yeah,
you're still using your laminar flow to make sure that you don't have contamination, but then you switch off the laminar flow to avoid the
evaporation.
evaporation. But you can't do more than 1 or 2 dishes at the
Yeah,
time.
that's true.
Ideally, yeah.
That's true.
Ideally,
So
one person can do media.
we have another
Yeah.
question here. So can we keep dishes filled with distilled water in each compartment to keep the chamber humidity if you're using dry incubators? Now, this is a good question.
It is. And as long as obviously you don't contaminate your distilled water with the culture media, so obviously you need to make sure that it's going to be in an area where you have to avoid spillage and accidents, but we all know that we have to avoid that. Actually, one of the papers, when they were using to humidify the environment, and that was Mohamed Fawzi's paper because he used the G185.
Yeah.
Way that he humidified the G185 when it was dry was to actually use a 10 ml of sterile water or culture medium, I can't remember now, in the Petri dish, and you refilled it on day 3. So that was his way of helping with humidifying the environment.
So you said 10 ml.
Yeah, so we haven't done the experiment on that. And that's actually one of the ones I was going to tell Steve that it could be a good experiment to do, is to check that. But obviously that's going to improve your humidity levels to raise higher than the 10% relative humidity.
Awesome. Okay, so is it advisable to store oil in the incubator? If yes, for how many days? So I think the question probably means that for how many days can you keep oil in the incubator?
So most of the companies test their oils because remember that oil is still a petroleum-based product. So we need to do our tests on oil. And most companies do their oil with the longest time that we have seen oil in use. So that's 7 days.
Okay.
Most companies. It depends from one company to the other, but I would say on average 7 days.
Okay. Now, so this question is, so in a humidified incubator, would changing media on day 3 still help? Like, we know that it helps in a dry incubator, but for a humidified incubator, especially when we're using single step, would it still help to change the media on day 3?
In a humidified environment, you see here that you've only got about a 2 milliosmol change per 24 hours. So even after, so let me see, day 7, you haven't reached, you reach 300 milliosmol at only around day 5. So probably in a humidified environment, you don't have as much of a problem. If you compare a change of 7 milliosmol per day compared to under 2 milliosmol per day, I would say in a humid incubator, you don't have such a drastic problem. So you probably don't need to.
Another one here says, what is better so do you make culture dishes a day before, or you make culture dishes half an hour prior using pre-equilibrated media? So as far as, yeah.
So if you use pre-equilibrated media, okay, you have to think about that in your own lab. Do you really have the time to make dishes in a controlled way? So making sure you don't do more than 1 to 2 dishes at a time. If you're using pre-equilibrated medium, of course you could do that if you wanted to, but you need to figure out what your patient load is.
Yeah.
You could rush things.
Is there any study to suggest that there are more osmolality changes in pre-equilibrated media as compared to when you just make the dish overlaid with oil?
So when we did it in our hands, the pre-equilibration, because you can see that it doesn't change anything pre-equilibrating or not in dry environment.
So this is oil.
Oh, sorry.
Oil. So when you're pre-equilibrating culture media,
yes,
obviously what people do is that they'll just put it in test tubes and leave it like that for overnight most of the time.
Yes.
And on the other hand, when you're making a culture dish and leaving that overnight, which is overlaid with oil, do you see a difference between the osmolality changes in between the two?
That one, I haven't seen a paper talking about that, but that's a good question. Have you seen it?
No, I haven't seen it. That's the kind of question. That's what came in our head right now. So maybe I'm going to look for a few papers and share it with the group then.
Yes, that would be good.
Yeah. If we use media from one company and oil from another company, does that make a difference?
Okay, of course, every company is going to say
yes, it does.
Yes, it does. Look, we did a fair experiment by using 9 different oils from 5 different companies. It depends on you. It's not going to make a change. It depends on your own research on the oil and asking the company representative or the clinical specialist more data on the oil. But no, in the incubator per se, it's like saying, do I need to use a certain media for a certain incubator? Of course, I'm going to say yes, because we have evaluated our media with our incubator.
Yeah.
I would prefer you to use cook oil, but that's just me.
No, so did we touch upon the fact that, so I don't know if you answered this question, but is mineral oil and light oil and paraffin different as far as these changes are concerned?
So, yes. So
because this graph shows that they're different, but we don't know which one is which. So
yeah, and I can't here in public tell you which is which.
Yeah.
Because it's not fair towards the different companies. I will look again at the graph and find for you. Can possibly say something on the paraffin oil and the mineral oil. Let me just have a look at that.
Sure. In the meantime, if you have any more questions, we can take maybe 1 or 2 more before the time ends. So you can just type those questions in, and please do go to the poll section and fill up the feedback. There are 94% of them saying that this webinar was very useful. One is saying that it was maybe useful. So hopefully the questions do change your mind as well. And thank you all for attending. If you have any more questions, we'll be happy to answer a few more.
So what I'll do, Keshav, is I'll send to you if there was a very specific difference between mineral oil and paraffin oil without saying which was which.
Yeah.
I will be able to tell you, if there was a very strong difference, because I can't see it in the graph that I have. So possibly I don't even have which is which oil.
Okay.
I'm looking here and I see that someone said that changing on day 3 in dry incubator, giving good blast rate with 1 step from
Chile.
Yes.
Yeah, that's what's expected, but yeah, we need robust data for it. So any suggestions on group culture or single embryo culture when using a dry incubator?
Well, that's where I actually wouldn't be able to tell you, because there's a lot of papers that are saying that single culture is better and others saying that group culture is better. So it's not really related with a dry incubator. I think it's more related to the embryos per se. But then you've got, it's different from one author to the other.
Yeah. It basically says that even if you're using a dry incubator and you're doing a group culture, the amount of embryos in that droplet would not really affect the osmolarity, because that's obviously not correlated at all.
Yes, it's independent from that.
Yeah. So any more questions from the group?
Please feel free to, if you have any questions that come up. I have, at the start of the questions, I wrote down my email, but I'm going to write it down again. And if you don't grab my email now, Keshav does have my email. I'm always happy to answer questions or to, do my best at answering them. Even if I don't know the answer, I'll find it out for you.
And Sonia, would you be coming for ISAR this year?
Actually, I just got told yes.
Awesome. So people who are actually attending ISAR can actually meet Sonia from the 6th to the 8th of March in Hyderabad, and maybe ask your queries there.
Yes. So this has just been confirmed to me that I will be present at ISAR this year, and I'll be on the Cook Medical booth. But if you don't want to talk Cook Medical, you can just grab me. We can go talk somewhere else.
Awesome. So thank you so much, Sonia, for conducting this webinar. I'm sure it was very useful for the audience. I also learned so much today. And
it's a pleasure.
And you've done a great job, and we're looking forward to have you do a few more with us. Maybe we'll take this discussion on email later on. And thank you to the audience for attending. Thank you for being interactive and asking so many questions. And do put in a feedback for us at the ISAR email, or you can even mail it to Sonia. I'm sure all of you enjoyed it. And if you have any questions which were left, please do ask us, and we'll be happy to answer. So with this, thank you again, and hope you have a great day ahead. Bye-bye.
Thank you so much. Have a great day. Bye.